All right, guys, so we are going to be working on 3-6 compound inequalities today. So all that this means is compound inequalities means that there's more than one inequality and they're either joined by the word and or by the word or. So first of all, let's work with the and side. So let's just take a look at this whole left-hand side. So when you go to the store and you say, I want a soda and a burger, you're expecting both, right? You're not expecting one of them, you're not expecting none of them, you're expecting both. So that's going to be the same thinking that goes into and compound inequalities. So let's start by graphing x is greater than 3, and I'll show you what happens. So we have 1, 2, 3. Greater than 3, greater than or equal to, means that we have a closed circle, and then we are greater than or equal to 3. So everything to the right. So now let's take a look at, let us take a look at, I want blue. At x is less than or equal to 7. So less than or equal to 7, we have a closed circle at 7 and everything to the left, okay? So now if we want to draw this compound inequality, that means that it has to be everywhere both graphs are intersecting, where there is both of them. So it's really going to be from this point all the way to this point. That's where my red is and that's where my blue is. So the answer and the graph to this compound inequality is going to be that my x is between 3 and 7 because that's where both of these graphs are. So, and sometimes I like to think of both, where they're sharing territory. So another way that you can write this is that x is between, so x is between 3 and 7. So 3 is less than x, and x is less than 7. So this is another way that you can write this and statement, okay? So if we take a look over here at the ors, so we're going to graph it the same way. So if you go to the store again and you say, I want a soda or a burger, and your friend comes back with just a burger, that's fine, right? You said or. You didn't say both. You didn't say and. So or is either or. It doesn't matter. They don't have to be in common. You don't have to share. So let's first graph x is less than 2. So we have an open circle at 2 and everything less than 2. Now, we have x is greater than or equal to 1. So x is going to be, this should be a negative 2. Delete. This should be a negative 2, okay? So we're going to have an open circle at negative 2 and everything to the left. Now for x greater than 1, we have a closed circle at 1 and it's greater than 1. So when we are writing this or inequality, when you see this word or, you are looking at everything. Doesn't matter if they overlapped or not. So your full inequality graphed is just going to be everything that you took from above. Okay? Now there's no way to write this like you wrote the and statement. It has to just be both of these separated by or. Okay? We're going to dive deeper into this, but it's really good to have this on your main page, okay? So let's begin by writing compound inequalities, okay? So this first one says that all real numbers are greater than negative 2 and less than 6. So we see this and statement, right? So that means I'm doing two inequalities that are separated by this and statement, okay? So the first one is this part. So it says all real numbers, let's say all real numbers are x, that are greater than negative 2, and all real numbers that are less than 6. Now, since this is an and statement, you can write this as an and inequality, like a compound inequality together. So that means that x is between negative 2 and 6. Okay, so either one works. I like the compound one better. because you can physically see that x is between -2 and 6. Okay? So next up we have that all real numbers are less than 0 or greater than or equal to 5. So that means that we have two inequalities that are separated by or. So the first one says all real numbers, x, that are less than 0 or all real numbers that are greater than or equal to 5. Okay? So this is the only way that I can write an or statement. You cannot combine them like you did up here. Okay? We are going to move on. So, move this up a little bit. So, we're going to solve a compound inequality involving and. So, as you can see here, there's no and there's no or. But we know from the past two slides that if it's written with this variable in the middle, it's an and statement. So, this looks funky. I know there's two inequality symbols with a variable in the middle and something else going on, but it works just the same. So I need to get my m alone. That's the whole point. So I need to get rid of this 4. So in order to do that, I need to add using inverse operations. Now the only difference about this is we need to do it to every side of the inequality. So that means that I'm adding 4 to the right and I'm also adding 4 to the left. Sounds weird, I know. You'll get used to it. So let's simplify. -3 plus 4 is going to be 1, is less than or equal to m, is less than -1 plus 4, which is 3. So I'm going to graph this. I know that m is between 1 and 3. So 1 and 3. Now my 1, it's a or equal to symbol. So that means that I have a closed circle at 1 and an open circle at 3 and everything in between. Okay? You guys will get the hang of it, I promise. So I want you to try this next one. So there's going to be 2 steps to get this y alone. You're going to add 4 first, then you're going to divide everything by 3, and you'll have your compound inequality and you'll be ready to graph it. Okay, let's do a different color because I'm sick of that one. So now we're going to look at the or. So as we know, or will always be written and I'll have 2 separate inequalities. So let's solve each by itself. So this first one is 3t plus 2 is less than -7. So first of all, I need to move this 2. So I'm subtracting 2 from both sides. I'm left with 3t is less than -9. I divide by 3, divide by 3. So I'm left with t is less than -3. Okay? So we did this one. Now we're going to do the one on the right. We have -4t plus 5 is less than 1. So we need to subtract 5 from both sides. Subtract 5. I get -4t is less than 1 minus 5 gives me -4. In order to get this -4 to the other side, we must divide by a negative. When we divide by a negative, we flip our symbol. So -4 divided by 4 gives me +1. So these are my 2 inequalities that I'm graphing. When it's an or statement, we just graph both as they are, and that's our answer. So to start, t is less than -3, meaning I have an open circle at -3, and my line going to the right. The left, I'm sorry. Now I have t greater than 1. I have an open circle at 1 and everything that's greater. This is my graph to this compound inequality with an or. Okay? So try this one on your own. You have, again, 2 inequalities connected by or. So whatever you get for y for both of these inequalities, you're going to graph both on the same graph, and that is your answer. Okay? Sometimes ors can be easier because we're what we're used to, and it's just 2 of them instead of 1. Okay, so you have a little, on your notes page, you have some of these definitions. I need you to write them down. So there's another way to write the solutions of inequalities, and you can use interval notation. So when we have open circles, we use parentheses, and I'm going to show you examples on the next page. When we have closed circles in our graph, meaning that we have less than or equal to or greater than or equal to, we use brackets. Now, sometimes when we draw an arrow on our graph, that means that it's continuing on to infinity or negative infinity, and we can use those symbols to indicate that. Okay? So let's give some examples. So, sorry about that. So, right here we have 4 inequalities that are written. 2 of them are regular inequalities and 2 of them are compound inequalities. And we are going to take the graphs and write the interval notation that it represents. So, just like we said before, here we have 2 and on, up to infinity, okay? So it's from 2 to infinity. So we want to write this notation. Now, our first number is 2, and our second number is positive infinity. Now, we have to look at, we have a closed circle here, right? Meaning that it's equal to. So we use a bracket. Now, whenever you have an infinity, no matter what, you use a parenthesis. So this interval notation can tell you that you're starting at 2 with a closed circle and you're moving on infinitely to the right because it's positive infinity forever. Okay? So we're going to take a look at this one as well. So we read from left to right. So we see that this graph is going on infinitely in the negative direction. So I have negative infinity and I'm stopping at 2. Now we just talked about how when we use infinity, we use parentheses. When we look at this 2, it's an open circle, so we also are using parentheses. So what this statement, this interval notation tells me is that my graph shows negative infinity to 2 with an open circle at 2, moving on infinitely in the negative direction. Okay? So, next up, we have a compound inequality with an and statement, right? Even though it doesn't say and, we know that x is between 1 and 5. So, I am starting at 1 and I'm moving on to 5. I have an open circle at 1, which indicates a parenthesis, and I have a closed circle at 5, which indicates a bracket. Okay? So, last up, we have an or statement, meaning we have 2 separate inequalities, right? Meaning that we're going to have 2 separate interval notations because we have something going on the left, and now we have something else going on the right. So, on the left, I see that we have negative infinity going on to negative 3. Negative infinity indicates a parenthesis. This negative 3 has an open circle, so we have a parenthesis as well. Then we have our or statement, and we're looking at 4 to positive infinity. 4 is a closed circle, which means a bracket, and infinity means a parenthesis. So again, this takes practice. I'm not expecting that you get it 100%. Please, please, please write down questions that you have because there are many to be answered that I probably did not explain in this video. So make sure you bring them to class and bring my attention to it so other students in the class can get those answers as well.